In this video, we're going to look at iodide salts reacting with concentrated sulfuric acid. So the solid iodide salt will have an acid-base reaction with the sulfuric acid. So sodium iodide reacting with sulfuric acid is going to produce sodium hydrogen sulfate and hydrogen iodide gas, which will mean that we will observe steamy white fumes, and they are due to the hydrogen iodide gas being produced. And the sulfuric acid is behaving like an acid because this is not a redox reaction because none of the elements have changed oxidation states. However, iodide is a good reducing agent, so the iodide ion is able to reduce the sulfuric acid to sulfur dioxide and then sulfur and then hydrogen sulfide, and we can write 3 overall equations to show this. So starting with the production of sulfur dioxide, so we would have iodide ions being oxidized to iodine, producing the electrons in order to reduce the sulfuric acid. So we would observe a black solid, and the black solid would be due to the iodine being produced, and that would be the oxidation observation or the oxidation product. The sulfuric acid will be being reduced to sulfur dioxide gas. And just as in the previous video, we're going from sulfur with an oxidation state of +6 in the sulfuric acid to +4 in the sulfur dioxide. So that means the sulfur needs 2 electrons on the left-hand side. We need 2 more waters to balance the oxygens for the right-hand side. And we need 2 hydrogen ions on the left-hand side to balance the hydrogen ions that we've got on the right-hand side. So the reduction observation would be the choking gas, which is due to the presence of the sulfur dioxide, and we could say the sulfur dioxide is the reduction product, or this is the reduction observation. So the overall redox reaction, I've got 2 electrons being produced in the oxidation half equation and 2 needed for the reduction half equation. So what I need to do is combine both sides together. I'm going to leave the electrons out because they are going to cancel, and that will give me the overall redox equation, which I can check to see if it's balanced by checking the charges on both sides balance, which it does. And that's the first redox reaction that happens. In the second redox reaction, we're going to produce sulfur. So the observations that we would see would be due to the iodide being oxidized to iodine. So we would see the black solid forming again. And the black solid is due to the presence of iodine, so that would be the oxidation product or oxidation observation. And this time the reduction is going to produce sulfur. So this time we're going all the way from +6 down to 0, which means we need 6 electrons on the left hand side. We need 4 waters on the right to balance the oxygens, and then we need 6 more hydrogen ions on the left-hand side to balance the hydrogen ions. So what would our observation be for this? Well, we'd see a yellow solid, and the yellow solid would be due to the presence of the sulfur, and that would be the reduction product or the reduction observation. So the overall redox equation, this time we should be able to see that we need to multiply the top equation by 3 so that we've got 6 electrons on both sides. So we just need to write out both sides, the electrons are going to cancel out. And then we've got the overall redox equation, and we can check, do the charges on both sides balance? Yes, they do. They both add up to 0. And finally, the third redox reaction that happens is the production of hydrogen sulfide gas. So the oxidation half equation is going to be the same as the previous two oxidation half equations. So we're going to see the black solid being produced as our observation again, and that's due to the presence of iodine, and that is the oxidation observation or oxidation product. And the reduction half equation, with this time we're going from sulfuric acid to hydrogen sulfide, and we're going from a +6 oxidation state all the way down to a -2 oxidation state in the hydrogen sulfide. So we need 8 electrons on the left hand side and 4 waters on the right hand side to balance the oxygens, which means that we need 8 hydrogen ions on the left hand side to balance this equation. So the observation for this would be due to the hydrogen sulfide, so the bad eggs gas, and that is the reduction observation or the reduction product. So the overall redox equation, we need to times the top one by 4 so that the number of electrons on both sides is going to equal 8, and then we can combine both sides together. So that we've got the overall redox equation, and you can see again that the charges on both sides add up to the same number, so that one is good. Okay, so the iodide ion reduces the sulfuric acid to hydrogen sulfide. Hydrogen sulfide has got the lowest oxidation number of the sulfur in all of the sulfur containing species that we've seen, which means that iodide ions are the most powerful reducing agent out of the halide ions, and in all of these redox reactions the sulfuric acid is acting as an oxidizing agent as the sulfur is accepting electrons.